Okay, now we're going to combine all the transformations and see and try to get the formula or whatever they're asking us. So it says find the equation of the image, which means just find the rule of y equals square root x. So that's the original under a dilation factor of 2 from the x-axis. So when we say dilation from 2 from the x-axis, we know that affects the y. So if we think about the y, a dilation, so we're going to see 2y happen there, and followed by a reflection in the x-axis. So when we see a reflection in the x-axis, we also see the y become negative. So this one, nothing has happened to the x here. So let's have a look at that here. So if we wrote we need to transpose these. So y divided by negative 2, or image y, equals the image y. So I'm going to put that, and that's where we see our original. So we've got the original was this, but I'll use it, that y is actually y over negative 2, and it equals x hasn't changed, the square root of x. So if I rearrange this, we can see that we have negative 2 square root x. So that's the new image formula there. So we would have normally just seen and said dilation factor of 2 by, so that's when the whole function's multiplied by 2 from there, and then a reflection in the x-axis means the whole function's made negative, which we've done that there. Okay, the second example. So we've got y equals square root x. Apply the following transformation. So a dilation of 2 from the x-axis. So from the x-axis means it affects the y value. So image y will be 2y. So if you read 2 divided by equals y. So if we wrote this formula out, that's the original, but our y is actually y over 2 equals, and x stayed the same, so equals square root x, so therefore it is y equals 2 root x. A bit the same. So then if we had the same y, a translation of 2 units in the positive direction of x, so we know that image x is going to be the x plus 2. If we transpose that, it would be x minus 2 equaled x, and so then we wrote out the formula y equals square root x, but then sub in our new things, y remained the same here because it was just that. So we get y equals and it's not square root, it's x minus 2. Okay, so we know the minus 2 normally moves our graph over that way in the positive direction. Okay, the last one, 3, we're going to change the graph 3 units in the negative direction of the y. So x hasn't been changed, but y has gone negative, so y minus 3. Okay, so if we rearrange that, y plus 3 equals the normal y. So we'll put these two things into our formula, y equals square root x, but we said y was y plus 3, and we said x is x. So here we go, and then if you move that 3 over, we get minus 3. And that was what we would use that graph if we were sketching that graph. We'd move the tick down 3 like that, and that would be on 0, negative 3. So we can see it hasn't moved. This original would have looked like that. So x is still 0, but the y's moved down 3. Okay, so when we're doing all these transformations, if they're giving you an order to do them, we do them the way they said. So let's have a look at this graph. So they're saying that originally the graph is like y equals x, and then they want us to do the following transformation. So a dilation by a factor of 1/3 from the y-axis. So we know that when it says from, the x is affected. So the image x will be 1/3 of the original x. and the y didn't change. So if you transpose that, we would have 3x equals the x. So down over here, I'm going to do it. So we have, sorry, I might do it over this side, sorry. Oops. So the first step is we're going to see, so y equals x, but we're going to change it, and we know that it's actually y equals 3x. This is using the first one. Okay, then we've got the second step is a reflection in the y-axis. So that means that x, image x, becomes negative. Okay, so negative equals x. So into that, every time we see x, we're going to put negative x. So we get y equals negative 3x here. Okay, and okay, and number 3, a translation of 2 units parallel to the x-axis. So x has been equals the original plus 2. So we're not doing anything with the y at the moment. So if you rearrange that, that'd be x minus 2. Yeah, equal to x. So if I put that in, instead of seeing x, I get x minus 2. And then the last one, a translation of 1 unit parallel to the y-axis. So y is the y plus 1. So if, and the x didn't change, so I've got y, if you transpose that, that'd be y minus 1 equals y. So I've got minus 1, negative 3x minus 2. But we bring that negative 1 over and it becomes plus 1. So there's our new formula. Okay. You could expand this bracket out and it could be y equals negative 3x plus 6 plus 1. So y equals negative 3x plus 7 could be the formula too. But either way, I don't think it really matters, unless they ask you. But in a multi-choice, you might get 2 options, so just be careful. So if I just did it the normal way, like so I've got y equals x, and then I know a dilation of 1/3 from the y-axis, so that affects the x by the inverse, so it'd be 3x. And then we know the reflection in the y-axis makes the x negative, so then I make that negative x. And then, so that's 1, 2, and then we know if we want to move the 2 units parallel, so it's plus 2, you know when you do that, you need to have, if you're going plus 2, you need it minus 2, and then if it's going 1 positive unit up, you would then know it's like the just plus 1 out here. So you can see we can get the same. So this is what we're sort of used to over this side, but to show we can use the point system, and it's going to help us with matrices, which we do soon. Okay, so as I said before, when we do transformations, when the one before, they told us how to do it, which one had to happen first. If you don't know, generally we follow this. What happened first, we follow this Dr. T, which means dilations are done first. So dilations first, then followed by reflections done second. And then we do any translations last. Okay, so, you know, third or whatever. Okay, so that's going to come up in what we have here. So it says find a sequence of transformations which take place, which take the graph of this. So this was our original, so this was the function, and to the graph of this. So this is our image. So they want you to write out what happened to that graph. So if you were just looking at it by inspecting, you can see this would have moved it to the right by 2. This would have moved it up by 3, and this the 2, it's only affected the x, so we're going to say it's a dilation of 2. Well, we do dilations first, so maybe it's a dilation of 2. So let's have a look. We don't know where it happened. So because they haven't speculated what happened, we'd say the dilation happened first. So that means just the whole function got originally. So let's have a look anyway. So if we do it in our image, so we started off with the normal point, okay? Now let's have a look at what happened. If we do dilations, we can see that it has been so this 2, the dilation factor, would have just been multiplying on this bit. So that means that the whole function was dilated first. So when we say that, it's a dilation of 2 in the whole function. So from the x-axis, or it affects the y. So if we were thinking of our new image, let's just write them out and then we'll do the formula at the end. So x remained the same for the first part, dilation. Then we're going to say the y got 2, so 2y, okay? Now the next part, we do reflections, and then there's no reflections here, so we will then do the translation. So I'm going to say it moved right by 2, so that affects the x, so the x got a +2, and the y moved up 3, so the y got a +3. Now let's rearrange these so we get the normal x by itself, so it'd be x minus 2 equals x, and this one will be y minus 3 divided by 2 equals the normal y. So you've got to move the 3 first and then divide. Okay, so then if our original formula was y equals x squared, let's pop what we know, but we said y was y minus 3 over 2, and we said x was x minus 2. So now you just rearrange this to get y by itself. So if I move the 2 first, that would become y minus 3. Now the 2 has to multiply everything there. Sorry, that should be minus squared. So it has to minus everything, times everything there, and then we'll move the 3. So we get 2x minus 2 squared plus 3. So see how we've done that. So find a sequence. We can say the answer for that was, so first what did we do? We did the dilation. So we will say first we did a dilation of 2 from x-axis. The next thing we did a translation of 2 positive 2 or 2 in the positive direction of x-axis, and then we did 3 a translation of 3 in the positive direction of y. Positive direction of y axis. Okay, so you've written it out, the form.